Hello and welcome to my presentation for MAE/ECE 535, the demonstration project. My topic is a magnetic flow meter and my name is Matt Benbow. A magnetic flow meter, also known as a magmeter, is an instrument used to measure the velocity of a fluid flowing through a pipe. The magmeter has the advantage of being able to be used in harsh environments and can also be used with a diverse set of fluids. Of the requirements for the fluid to be measured with a magmeter, two of the main ones are that it has to be a conductive fluid and the fluid cannot be magnetic. Magmeters can also measure the flow of fluids with suspended solids. For these reasons, magmeters are a great choice for the pulp and paper industries, wastewater industry, and oil and gas industries. The working principle behind a magmeter is Faraday's law of induction. The common phrasing for Faraday's law is the electromotive force around a closed path is equal to the negative of the time rate of change of the magnetic flux enclosed by the path. In an equation form, the generated voltage is equal to the negative of the change in flux over time. By a few substitutions, we find that the generated voltage is also equal to the flux density times the length of the conductor times the velocity of the conductor. In the case of the magmeter, the generated voltage is also multiplied by a coefficient of proportionality, K. By holding the flux and the pipe diameter constant, the generated voltage will be proportional to the velocity of the fluid. The four parts of a magmeter are a voltage sensing device, in my case a multimeter, the pipe that encloses the fluid itself, and a magnet that produces a magnetic field. I will now show you a demonstration of the magmeter working in practice. The multimeter is set up to measure millivolts between the two electrodes. Initially, before the fluid flows, we see that 0 millivolts are being recorded. Then, as the water flows through the pipe across the magnetic field, we can see that the millivolt changes from being around 20, and then it gets their steady state value around 14.7. Then that value is recorded, and then the velocity of the water is increased by turning the spigot a little bit more. You can see as the velocity of the water increases, the voltage measured across the electrodes scales linearly with the speed of the water coming out of the hose. This view shows the experiment setup. You can see the 1-inch cubed N52 magnet at the bottom, then you see the tubing that has the water coming out of it, the electrodes that are leading to the multimeter, and of course the multimeter that's measuring the voltage. Many electromechanical devices can be operated in reverse. In the case of an electric motor, you can generally operate them in reverse as an electric generator. In the case of the magmeter, it can be operated in reverse as a magnetic pump. This diagram shows the experimental setup for the magnetic pump. This diagram is essentially the same as the magmeter, except the pipe has been replaced by two long aluminum rails. You can see here, as I connect the 9-volt battery, thus closing the circuit, we will start to see fluid flow across the magnet. This is better illustrated by using props or dies to really emphasize the fluid flow. The equation governing the force on the liquid by the magnetic pump is Lorentz force. This is current times the length between the conductors times the magnetic flux. In this case, since the magnet and the length between the conductors does not change, the force is directly proportional to the current, much like how the velocity was directly proportional to the generated voltage of the magmeter. This means by increasing the current between the two conductors, we can increase the force on that liquid being pumped. In conclusion, magmeters are a very interesting instrumentation device that are used to measure fluid flow. They are based on Faraday's law of induction, and the generated voltage is proportional to the velocity of the fluid. Magmeters can be operated in reverse to act as a pump. In the real world, magmeters use an electromagnet and an alternating signal to reduce noise in the system. However, the operating principle of these magmeters versus the one I've demonstrated is the same. Thank you for watching my video, and I'm looking forward to watching everybody else's.